Going through the work that I had posted for you today. A couple of people got back to me having a couple of issues with it, so I just wanted to run through the explanation of what's happening in the examples that are here, and then run through a few of the questions and hopefully makes a bit better sense. So you guys have finished work on quadratic functions for me today, and hopefully the problem questions that I've given to you today based on the work that we've done last week weren't too much trouble. The new part is to do with transformations then. So when we transform something, we're changing it or moving it. Essentially, that's all that's happening. And we have 3 examples here of how a quadratic function can change. So the first one is when we change the coefficient that is attached to the x squared value. So the coefficient is the number in front of the x squared value. So you can see in this example here, I'll go with this one. In this example here, we've got the black curve is x squared, y is equal to, actually, we'll do it in the colour that it's supposed to be. That makes more sense, doesn't it? We'll do y is equal to x squared, and that's the black curve, and that's fine, okay? When we increase the coefficient, when I put a number in front of that x squared, all we can see is what's happening to the curve is that it narrows, that it becomes sharper and steeper in what's happening. It still goes through 0, 0, because if x is equal to 0, then we get 0 still. And if it's 2x squared and I sub in 0, I still get 0. So that doesn't matter. So what's happening? All that we see is that we see that curve becoming narrower and narrower. And if I had 4x squared or 5x squared or 10x squared, it would be narrower and narrower again. It would start coming in here. It would start making a curve in here that's even narrower and narrower again. But they'll all go through 0, 0. Okay? So that's all that's happening. And that's what the maths that's involved here is telling you. We have it here. When a is greater than 0. So I'm looking at the function in the form of ax squared. So ax squared, they all look like that. This one's 1x squared, that one's 2x squared, that one's 3x squared. So the a value is changing. Once that a value goes up, it's just getting narrower in the curve. When I add numbers to it, instead of putting a number or changing the number of the coefficient of the x squared, if I add a number to the x squared value, so you can see there, again, I've got y is equal to x squared as my base, is my basic one that we're looking at. In the blue one, I'm adding 3, because I have y is equal to x squared plus 3. All that's happened is that the graph has shifted upwards, and it's moved up by the amount that I've added. You can see it moved up from there, from 0, 0. It's moved up 1, 2, 3 spaces. And that's it. The curve is still the same shape. It hasn't got narrower like the ones that we did up here, because I haven't changed the x squared. It's still x squared. All that's happened is that I've added 3 to every value. So it just moves up. So imagine if you are actually doing this maths. I've got x squared. And if I sub in 0, I get 0. If I sub in 1, I get 1. If I sub in 2, I get 4. So the points there are 0, 0, 1, 1, 2, 4. Okay? And I'm getting points on this. You can see that 1, 1 is a point. 2, 4 is a point. Now I'd also get these on the other side, because minus 1 squared is 1. Minus 2 squared is 4 as well. So you're getting those points. If I add 3 to each of those, what happens? If I add 3 to 0, it gives me 3. So the point would now be 0, 3. And that gives me that point there. I'll do it in blue. If it's 1 and I add 3, like the function tells me, it would be 1, 4, which is there. And you can see it. 2, when I sub in 2, I end up with 4. But if I add 3 to that, it'll become 7. So it's 2, 7. And that point is there. So when we're adding a number, all we're doing is we're pushing the graph upwards. The same way if I had a negative value. If I had the function of y is equal to x squared minus 2, let's leave that there, hang on, that's plus 3. If I make a new one and it said y is equal to x squared minus 2, what would happen is the black curve is my base and I'd move everything down 2 spaces. So my bottom point would be there now. And everything else would be the same kind of curve. It's just 2 points lower. Okay, now it's obviously not perfect because I'm not graphing it, but you get the idea. It's just moved downwards because I've got a negative, and it moved upwards when I had a positive. The final part of this one is if it moves to the left or right, the graph. That happens when I add a number to the x value, and then it's all to be squared. So you can see it's in brackets. So the difference that you need to make sure we're clear on here is the difference between this second one that I've done and the third one, okay, that we're going to look at now. You can see again, our base is y is equal to x squared. And the red one in this case is equal to y is equal to x plus 1 squared. That's different to doing x squared plus 1. I hope you can see the difference between those two. If it was x squared plus 1, all that would happen is that the curve would shift up 1 space, like it did in the previous problems, where we added 3 and it went up 3 spaces. In this case, I'm adding 1 to the x value, and all of that is squared. And what happens with that then, it moves to the left hand side. If I was to subtract, if I had a different one where I had y is equal to x minus 1 squared, what would happen is the curve would move to the right, so that the curve would end up coming down and it would do this. So you can see that it's moved to the right of the original one, which was the black one. The mathematics involved are not difficult. The process of plotting points is exactly the same as what you've done for any of the other graphs before. I just wanted to show you these to give you an idea of what happens to a curve when it moves. So we'll look at the example one and then we'll call it there. I might make another video then to run through the example questions. So the question asked here to graph the function in the domain -5 up to 1, and then use our graph to sketch the other graphs. So the first part is to sketch a graph. You guys have no problem doing that. I have my function x plus 2 squared, and I want to graph it from -5 up to 1. So you guys can draw out an input-output table like that, sub in all your values, get your x and y coordinates, and then you plot your graph like has been done there for you. That's no issue to you. You were able to do that last week, so I hope you're still able to do that this week. The new part of what it's doing is it's asking you, based around that info, you should be able to sketch. Okay, now most important thing here, it says sketch. It's not asking you to plot. It's not asking you to redo this for the new function. It's asking you, based on your knowledge of what's going on in the graph drawing, how will that change? So the first one, the first new function is the gx. G of x is equal to x minus 1 squared. Now look at that compared to the original. Instead of x plus 2 squared, it's x minus 1 squared. So what's changed? It's gone from plus 2 to minus 1, which means I've subtracted 3 inside that bracket. Now we go back. This is the same as what's going on at the bottom here in step 3. In step 3 down here, I'm going to get rid of these and we'll start again. So if I have a graph like the x squared, and I subtract from that in the brackets, So instead of having x squared, let's get rid of that again, sorry. Instead of having x squared, I now have x minus 3 squared. Let's say for example, if b is negative, if the number beside the x is negative, the graph is shifted that many units to the right. So it's moving 3 spaces to the right from where it was originally. So that's what this function now is telling me. The change from +2 to -1 is a change of 3 minus 3. So it will move 3 units to the right. Okay? It will move 3 units to the right from where it was originally. So this is where it was originally, and I'll move everything 3 spaces to the right. 1, 2, 3. So the base of the curve is now going to be here, and I'd be able to sketch and draw that curve again. It also gives you the info here. You can see you can work out where it hits the x-axis by putting y equal to 0. You can work out where it hits the x-axis or where it hits the y-axis by putting in that value. Okay, that's the info that I've told you there. The graph is shifted 3 units to the right. So all we've done is we've moved this point 3 units to the right, that point 3 units to the right, that point 3 units to the right, and all the way across. And that's it. Okay, and you can see it there. Because I've gone from +2 to -1, I've shifted it 3 spaces to the right. In the next one here, we can see the original again was x plus 2 squared. That was the f of x, wasn't it? At the start. And now my new one, the h of x, is x plus 2 squared minus 5. Now, it's outside the brackets, so I'm not moving to the left or right. It is the same as what we did in the second one here. So remember what we've written. If it's a plus value, we're moving upwards by that amount. If it's a negative value, we're moving downwards by that amount. So in this one, it was x squared to x squared plus 3, so we went up by 3 spaces. In this one, I'm going from x plus 2 squared to x plus 2 squared minus 5. So we're moving down 5 spaces. So the graph looks the same. It stays the same shape. All that's happened is that it's moved down 5 spaces. Look. 1, 2, 3, 4, 5. And the same with that one. Dropped 5 spots. Dropped 5 spots. Dropped 5 spots there and there and there. That's all that's happening. Okay? So that's the explanation done. As I said, go back over it, have a look, pause, rewind, do whatever you need to. I'm going to put up another video now of the example problems. Thank you.